In the previous video, I have discussed about two probable short questions on Laplace equation in electrostatics. Number one is your define Laplace equation in define and explain Laplace equation in electrostatics. And the second question I have discussed that you prove Laplace equation in electrostatics from Gauss law. In this video, we will discuss another short questions generally asked in the examination, that is write the physical significance of Laplace equation in electrostatics, or what are the significance of Laplace equation in electrostatics. There are two basic significance of Laplace equation in electrostatics. Number one, the Laplace equation is used to find electric field in regions where there is no charge or charge free region. Your Laplace equation is Laplacian phi equal to 0, and for charge free region the charge density is equal to 0. So Laplace equation in electrostatics will be applicable for regions where there is no charge. For example, charge inside a conductor or charge in a conductor in vacuum. We know inside a conductor there is no charge. Charge resides on the surface of the conductor. So inside the conductor there is charge, that is the charge free region. Similarly, inside the inside the two parallel plates of a capacitor, if there is vacuum, then there is no charge. That means conductors in vacuum. So once the potential you calculate applying your Laplace equation, then you can also find out the electric field, because you know electric field is equal to negative gradient of potential. By using that formula you can calculate the electric field. And the second the second significance of Laplace equation is, we know that according to uniqueness theorem in electrostatics, for a given boundary conditions there is only one possible solutions. Suppose you have boundary conditions, given boundary conditions, then for any differential equation have one solution. This is the uniqueness theorem in electrostatics. For example, suppose there is vacuum in between two parallel plates of a capacitor, then the region is charge free region. In between two parallel plates capacitor, the region is charge free region because there is vacuum in between the two plates. So we can apply your Laplace equation. And what is the boundary condition? The boundary condition is at the two boundaries there is no charge in between the two plates. So charge density is equal to 0. Suppose at x equal to 0 and charge density, sorry, there is no charge in between two plates. There is no charge means the charge density, not rho, the charge density rho equal to 0 at x equal to 0, and rho equal to 0 at x equal to d. Suppose at x equal to d, if you have two plates, so one will be at x equal to 0, another at x equal to d. So this is the boundary condition. So applying the boundary conditions, you have only, according to this theorem, uniqueness theorem, you have only one solution. So the Laplacian equation, the differential equation given by Laplace, that is the Laplacian phi equal to 0, del square phi equal to 0. If you solve this equation, only you have one solution for potential phi, and if you find out the potential, then you can also find the electric field intensity from the well-known formula that field is equal to negative gradient of potential. So this is another significance of Laplace equation. So there are two significance of basic significance of Laplace equation. One is at charge free region you can find out the you can apply the Laplace equation to find the electric potential or field. Another, you can apply the uniqueness theorem to solve boundary value problems by applying uniqueness theorem and your Laplace equation can be solved using boundary value problems. So in the next video we will explain how these two equations, Laplace equation and Poisson's equation, they are applicable to method of images. Thank you.